to this lecture, we will be discussing in this lecture the concept of gradient, divergence and curl related to vector algebra. इस पर आने से पहले we will be defining two terms to us. What is a scalar point function and what is a vector point function. A point function is that which changes its value with respect to different points in a given region of space. We have seen this property in gravitation, we have seen this property in case of electric field. तो जब gravitational field या gravitational force हम किसी point पर लेते हैं एक mass के नज़दीक में, it may change because it is dependent on distance, so it may change from point to point. अगर एक point पर इसकी value unique है, it's a point function. So a scalar point function would be that कि अगर एक space के region R में हर एक point पर एक scalar quantity exist करती है और uniquely exist करती है और हर point के साथ साथ वो बदल सकती है. Now it is possible, it may not change also, लेकिन it must exist in a unique way corresponding to each point of that region of space R. We call it as the scalar point function. So formally, if corresponding to a point P each in a region of space R, there exists a scalar quantity associated with each point uniquely, the region is called as the scalar point function field or scalar field. Temperature distribution, जो इसकी examples हैं, temperature distribution in case of a hot body is a scalar field because corresponding to each point on the hot body there exists a unique temperature and temperature is a scalar quantity. Now we can think of a vector point function. A vector point function would be that if corresponding to a point P each in a region of space R, there uniquely exists a vector quantity associated with that point, then this vector field is defined in that region. Now this vector field or scalar field we can utilize for further going into something what we call as gradient of a scalar field, divergence of a vector field or curl of a vector field. As far as the examples of vector field are concerned, you are aware of the gravitational force in a region, you are aware of electric field in a region, you are aware of magnetic field in a region, you are aware of velocity field. That means when the liquid passes through a tube, each point has a velocity which is unique to that point, and that velocity being a vector quantity, it describes a vector field. Now as far as the dealing further is concerned, we deal with these two vector or scalar fields with the help of an operator called as del operator in vector algebra. So how we define a del operator, ये इसका symbol है, this is called as del or nebula operator. ये define किया जाता है as I into dou over dou x plus j into dou over dou y plus k into dou over dou y. So this is how we define nebula or del operator, and you can see that it is a differential operator. It is going to differentiate the function जिस पर ये act करेगा या operate करेगा, and it is a vector differential operator. So that means I cap, j cap, k cap, they give its components for different directions, that is x, y and z axis. We can later on use it for other coordinate systems also. Right now we are expressing it as for the Cartesian coordinate systems. Now this can further run into another operator जिसको हम del square कहते हैं. This is also called as the Laplacian operator. So if I take dot product of del with itself, I obtain del square. So you can see that once I take dot product, I dot I would be equal to 1, j dot j would be equal to 1, and k dot k would be equal to 1. So this becomes the Laplacian operator, Laplacian, or what we call as del square operator in the vector algebra. Next is that the moment we think of a certain scalar field or a vector field, we have a pictorial representation. One very important tool in case of representation of scalar fields is the tool of using level surfaces. What's a level surface? So if I have a scalar function f of x, y, z defined in a certain region of space, or say phi of x, y, z defined in a certain region of space, such that over a certain surface this phi, which is dependent on the values of x, y and z, remains constant over that surface, the surface is called as a level surface. Now think of an electric charge, say a positive charge setting up an electric field in a certain region of space, which we represent through the electric lines of force. And then we have a electric potential. So this is electric potential, electric potential. Now this electric potential remains constant over the dotted line shown red. This is what we call as an equipotential surface. So this is an equipotential, equipotential. Now this equipotential, you will agree with me, has the electric potential constant all along, and it is a level surface. So this becomes a level surface. Now equipotentials or level surfaces have a property that they cannot intersect. No two equipotentials can intersect. So passing through a single point, there can be always a unique equipotential. Through a single point, we cannot have more than one equipotentials or level surfaces which can pass through them. This property you are already aware in case of electrostatics, and it is to be generalized to all the scalar fields. Then when we think of now the equipotentials in a given region, there can be a number of them. जैसे यहाँ पर अगर मैं लूँ, so here all across this there is a value phi 1, across this there is a value phi 2. We can similarly have another equipotential with the value phi 3 and so on. So being imaginary surfaces, you can imagine that there is a continuous variation of phi. So we can start with phi and go to phi plus d phi and so on. We can make the changes from one to another through a large number of steps. The number of steps which we can take between two level surfaces could be infinite number of steps. So there is the continuity of level surfaces. From here we take two level surfaces. मान लें हमारे पास एक level surface है S1, surface 1, और एक और है surface S2. इस S1 पर level surface S1 पर phi है वैल्यू फंक्शन की, और जो दूसरा हमारे पास S2 है वहाँ पर है वैल्यू phi प्लस d phi, phi प्लस d phi. ये है S2. Call this as O. Call this point as P, P, and let the position vector of P is R. I take another point Q, Q on surface S2 and let the position vector be R plus dr, delta. So you'll agree कि जो ये vector है अब, this vector is the change in position vector. से अगर आप ट्राइंगल लॉ फिर से यूज करें, r plus dr would be equal to r plus delta r dr. So I'll call this as dr. So this is r plus dr would be that this is dr. I can think of the rate of change of phi now, because here the value is phi plus d phi, here the value is phi. So the change in value of phi from S1 to S2 is d phi, and this has occurred over a distance dr. So rate of change of phi with respect to r would be equal to d phi by dr. So d phi is the change in value of the property, the scalar function from level surface S1 to S2, and dr is the distance over which it has occurred. Now this change of phi with respect to r is not unique. अगर हम dr की वैल्यू इस तरह से चेंज करते रहें, like I could have taken point q here, or I could have taken point q here, or I could have taken point q here, तो आप देख रहे हैं कि since the magnitude of dr is changing, the distance covered between these two level surfaces is changing, this is not going to remain constant. So it's not a unique value, but we can make it unique. That unique value can be obtained if we go along the shortest distance between the two level surfaces, that is this direction. So this direction is the shortest distance, and I call this shortest distance as dn, and call this a unit vector, direction of unit vector n cap. तो जो ये shortest distance है, this shortest distance gives us the maximum rate of change of phi with respect to r. So if I have to define maximum rate of change of phi with respect to r, that maximum rate of change will occur in this direction, so that would be equal to phi divided by n. And this maximum rate of change has a direction. It is along the direction of n cap, so I attach a unit vector with it that gives us the direction of this change or rate of change. Now, thinking of this rate of change as being the maximum, we have a definition of gradient. This maximum rate of change of phi with respect to the distance occurring along a direction which is the direction perpendicular to this level surface. This is a direction perpendicular to this level surface, or it is occurring along the direction where it can be maximized. So we can maximize the rate of change along this direction. This is called as the gradient. So this maximum rate of change of phi with respect to r, which occurs along a certain direction so that the distance between two level surfaces becomes the shortest, the rate of change becomes maximum, is called as gradient of phi. So this is grad phi, that means the gradient of phi, which we will also denote as the gradient phi is equal to rate of change of phi with respect to the shortest distance between, taken for the shortest distance between the two level surfaces multiplied by the direction we are defining like this. अब आप यहाँ से देखें कि if you take this dr vector और this is dn vector और ये angle हम मान लेते हैं this angle is theta, you will agree that the component of this dr in the direction of n cap is given by the dot product of dr and n cap. So component of dr in direction of the unit vector, ये n cap एक unit vector है, would be given by the dot product of these two vectors. This is a well set formula as you can interpret simply through the dot product or scalar product. अब हम यहाँ ऐसा करते हैं that if I take a result like this, that I have already established that how we think of del phi or grade phi as derivative with respect to, or change of phi with respect to n multiplied by n cap. I can take a dot product on both sides. So I take del phi dot dr. ये dr का dot product मैं खुद ले रहा हूँ on both sides is delta phi divided by delta n into n cap dot dr. So I have taken this dot product on both sides. Now this n cap dot dr, you will agree from here that when you take the this dot product of dr and this dn or n cap, that way you will get this will be simply equal to magnitude of first into magnitude of second. So this is magnitude of first into magnitude of second into cos of angle between the two. So that is cos theta. So magnitude of n cap is equal to 1, magnitude of dr is dr, so this will be equal to dr cos theta. So now we have del phi dot dr is equal to dou phi by dou n into n cap dot dr. So here we can understand that this dot product is simply the component of dr in the direction of dn. तो अगर हम level surface A से B की तरफ जाते हैं, this would be dr जो भी आप देख चुके हैं. This is dn, dn. This is n cap. So this dot product n cap dot dr or dr dot n cap, क्योंकि commutative product है, would be the component of dr in the direction of dn. So that will be equal to dn. So I can say that del phi dot dr is equal to dou phi by dou n into dn, because n cap dot dr is dn. और otherwise also, अगर आप इस product को लेते हो इतने को, you will agree with me that this is how we have already defined del phi. We have already said that del phi is equal to dou phi by dou n into n cap, which is the rate of change of phi with respect to n in the direction of n cap that becomes perpendicular to the level surface. So ये जो अब result हमें मिला है, this result, I would say that if you go by the product here, this is simply the total change in value of phi, and that way del phi dot dr is equal to d phi. And this result would be of importance. अब देखिए इसका हम एक important interpretation किस तरह से लेते हैं. If I go back to a level surface, so imagine कि हम एक single level surface पर हैं और उस single level surface पर हम ये कहते हैं कि the value of phi remains constant. So if phi is equal to constant over the whole level surface, you will agree that d phi will be equal to 0. So if I imagine that I have a level surface, this is the level surface, and on this level surface, if I take the value of phi is equal to constant, it is equal to constant, therefore d phi is equal to 0. So this would mean that if I take for a level surface del phi dot dr, this would be equal to 0, because all along the level surface phi is equal to constant. Now what does that mean? Out of this product, when we have the dot product of two vectors equal to 0, that means that these two vectors are perpendicular to each other. And if you take this as the point where you have found del phi, gradient of this, so this would be the direction of dr and this would be perpendicular to level surface. So this perpendicular to level surface would be the direction of del phi, and angle between these two is equal to 90 degrees. So in other words, the gradient of a scalar function phi at a particular point, gradient of scalar function phi at a particular point is perpendicular to dr. Dr is along the tangent and the gradient takes place along the perpendicular direction to the given level surface. और इस रिजल्ट को हम एक इलस्ट्रेशन देते हैं. लेट्स गो बैक टू इलेक्ट्रोस्टैटिक फील्ड. इलेक्ट्रोस्टैटिक फील्ड में हम ऑलरेडी कह चुके हैं दैट देयर इज द description of an electrostatic field either in terms of the electric lines of force or in terms of equipotentials. So if I imagine that I have a charge here, point charge, this is the set of electric lines of force which this point charge produces, and this set of electric lines of force can also be having ये इसी region में हम अगर equipotentials लेते हैं. So these red dotted lines are the set of equipotentials which are present in this region. Now this each dotted line gives us a certain value of potential. चाहे आप उसको V1 कहो या phi1 कहो. So I call it as potential V1. This is potential V2. So at each point you can see कि अगर हम ये एक level surface लेते हैं having the value of potential V2, आप देखोगे कि this is the direction, as I said, of dr, and this is the direction of del phi. Del phi is that we have the direction of gradient at a point which will be given perpendicular to the level surface through that point. Or already we have noted that these level surfaces, which we call as equipotentials here, are unique. Through one point there can be only one level surface and not more. Or in that sense, you will also agree that whatever is the direction of electric field, that direction of electric field which is outwards along these electric lines of force, so this is the direction of electric field, has the direction same as that of del phi at a point, but we attach a negative sign with this relation, which means that the direction of decreasing potential, so this is the direction of decreasing potential, is the direction of electric field at a given point. And at each point you will agree that whatever is the direction of electric field is also that of the gradient, and gradient between two level surfaces is perpendicular to them. So this is how we can repeat the same in case of gravitational field also. तो ये अब सारी प्रोसेस जो हमारे पास एक ग्रेडियंट किसी स्केलर का हम लेते हैं, वो प्रोसेस अब ये बन जाती है that gradient of a scalar function phi is equal to del phi. So if I provide you a scalar function phi equal to x square plus y square plus z square plus 2xyz, and I ask you that find gradient of phi, find grade phi at point, let me say the point is 1, 2, minus 3. How to do it? Very simple. What we do is we find the gradient of this scalar function phi by introducing del operator and operating with del operator on phi. So I have I cap into dou over dou x of the scalar function phi plus j cap into dou over dou y of scalar function phi plus k cap into dou over dou phi, z of phi. So that way, when you differentiate phi with respect to x, keep the y and z as constants. So you will agree with me that when I differentiate phi with respect to x, so it will be I cap into derivative of phi with respect to x, keeping y and z constant. इसका derivative 0 हो जाएगा, इसका derivative 0 हो जाएगा, इसका derivative होगा 2yz, because 2yz is constant, derivative of x with respect to x is 1, so it will be 2x. So this is 2x plus 2yz. Similarly, when I repeat the derivative with respect to y, so this will be 2y, ये 0 हो जाएगा, ये 0 हो जाएगा, so here you will be left out with that y is now, derivative of y with respect to y is 1 or 2xz, so this will be plus j cap into 2y plus 2xz. Similarly, we can put k cap, so k cap into derivative of the phi with respect to z would be 2z plus 2xy. Return the values of this x, y, and z. So you have x equal to 1, y equal to 2, z equal to minus 3. So give the values of x, y, and z to the equation. You obtain value of gradient phi at a particular point. And remember that when you give the values to x, y, and z, you have the retention of I cap, j cap, k cap. That means जो आपका result होगा, that result will be a vector. And that vector represents the gradient of the scalar function at a particular point. This way, we have the transformation of a scalar function into a vector with the help of the del operator. Del operator का vector nature यहाँ पर एक बड़ा important role play करता है. Now you can pause the video and solve the problems as shown. Also, you can take some more problems of the same type related to this concept and solve them.